Hi everyone, my name is Helen, and today I'm going to present the project I just started working on for my PhD, which is the development of a protective hearing aid for workers in loud environments. 40% of Canadian workers have reported in a study to be exposed to hazardous noise at work. Hearing loss among workers is still prevalent, and current hearing protectors can't amplify ambient sounds to help the wearer perceive unlocalized sounds. Thus, to be able to hear and communicate properly, those hearing-impaired workers usually wear their hearing aids at work. Because hearing aids amplify ambient sounds without discriminating sounds of interest, their use in noisy environments can worsen hearing loss. What's more, none of these devices can monitor sound exposure. This is why there is a need to develop an intraoral protective hearing aid that could monitor an individual's noise exposure. This project will be conducted into two phases, the first one being the development and test of algorithms. Hearing aid algorithms will be implemented into a device with two earplugs, each equaling a loudspeaker, and two microphones. The second phase will consist in test and validation on human subjects. We are currently in the first phase, and as you can see on this graph, the implementation and test of algorithms will be made using two different programming platforms, which I'm going to describe now. We decided to use MATLAB in the first steps, for its easy use and access. The laboratory tests to adapt parameters and features from algorithms will be led on MATLAB. This will also enable us to work with the hearing aid algorithm coded in the MATLAB speech test environment platform developed by Ilham and Giga in 2014. Tympan is a hearing aid hardware and software development platform under MIT license used to offer an open source solution for hearing aid development. An additional feature that has a particular interest for our project is the stereo sound transmission, which would enable us to have even more possibility to personalize our prototype. Finally, Tympan has already coded codes for wide dynamic range compression that we want to use and thus transfer to MATLAB for future adjustments. The algorithm we're willing to use and that will be adapted from the MATLAB speech test environment platform includes single-channel compression. Wide dynamic range compression has been proven better when treating speech. The A-band should enable both good consonant and vowels recognition. As Tympan has an 8-band compression algorithm, and because it will be used for a final prototype, we're going to use it and transfer it to MATLAB for tests and adjustments. Here, we compared Tympan filter bank outputs and its logical spectrum implemented to validate the possibility to code in MATLAB the Tympan response. As you can see on this graph, the filters correspond to each other and cutoff frequencies are consistent. To conclude, we are working on the device combining sound amplification, sound attenuation, and noise dosimetry. We have been able to validate Tympan simulation from MATLAB script. This is the first step of our project, and we still have a long way to go. Thank you for your attention.